All right, real quick, everybody was pretty much here yesterday, right?
Yeah.
Okay. All right, so I'm just gonna step up to where we left off then.
We did that.
Okay, we did this, right?
Yeah.
Okay. And okay, here we were.
We left off here.
Okay, left off here, right? Okay, so to me, this one I would claim is a pretty simple one because all you got to do is recognize that graph, right? And so, in order to do this, is in what form?
H.
Yeah,
Vertex.
that's it. Yeah, vertex form with the H's and the K's. Good. So we just this is the form we're in. Right? And we just need to know the values of A and H and K, and that's it. That's all we require to find the graph of this thing, right? So, what is A?
Negative
one.
one.
What's H?
Hey, why
What's-
is Kid Hopper today? Why is he here today?
Is he here today?
I said welcome, Governor Kitzhoffer on
I don't know.
TV.
What's K?
It's 11.
11. Okay, so what are the coordinates of the vertex then?
5, 11.
Good. Okay, does it open up or down? That's all you need, right? The coordinates of the vertex are at x equals 5, y equals 11. So that's the point right there. And it opens down, and that's a good sketch of the curve.
And it opens down because it's negative?
Because A is negative.
Okay.
Yeah. Okay.
Why is
Hey, Nikki.
5 positive? Why is H positive?
Well, because look at the standard form. It says x minus h squared. Well, so then x minus 5 would have to be h, right? Because we're subtracting h from x. So what number, wouldn't you agree, h is the number that's being subtracted from x, right? So what's the number up here in this equation that's being subtracted from x? 5. So it's positive, right? So remember our little rule with that. We know that that the sign of h is always going to be opposite of that.
So if it was positive, it'd be negative 5?
Yes. Because if it was x plus 5, we'd actually be subtracting a negative in that case. So just as kind of a rule of thumb, you just always know that the sign of h is always going to be the opposite of that operation up there. Okay? Make sense? Okay. Oh, didn't write the expression down.
Yeah.
Might be helpful, wouldn't it? Okay, this one was, I know what it was though. It was a product of complex numbers. So say we had something like this. 2 plus 3i times 4 minus 2i. Okay, if we're trying to write this in the form a plus bi, standard form for a complex number, we want to know what's the real part, a. Okay, so how do we do this one? Just FOIL it out, right? So we're going to get, if I FOIL this out, first times first gives me product of the outer terms, inner terms, product of the last terms.
Negative 6i squared.
What's I squared equal to?
Negative
Yeah.
1.
Negative 1. So then this term just becomes, we can just replace that with a plus 6, right? Okay, and so our final answer then just looks like, if I add up like terms, what am I going to get?
14 plus 8i.
So what's A?
14.
14. You got it. Okay. Find the greatest real solution or complex solution with the greatest imaginary coefficient. Okay, so what are we going to do with this one?
U minus 4x
terms, we gotta put it into standard form, right? So we're just gonna set it all equal to 0. So if I subtract, if I start off with 3x squared plus 21x plus 15 equals 4x plus 4, and I subtract 4x and subtract 4, what do I get? 3x squared plus 17x plus 11 equals 0. And what's my obvious strategy for solving that? Quadratic formula, sure. Right, quadratic formula. So if I plug all it, well, let's write down a quadratic formula. X equals
Negative b plus or minus square root of b.
There you go.
Subtract
4ac
divided by 2a.
Okay, and remember, it's all divided by 2a. The fraction bar goes under the whole thing, right? So if I plug this stuff in, then don't I just get what's negative b?
Negative 17 plus or minus 17 squared, subtract 4 times 11 times 3
Good.
divided by 2, 3, 6 divided by 6.
Okay. Right, 2 times a, 2 times 3. Okay, and so how was that? 289 minus 132. So 289 minus 132 is 157. Is that right? Square root of 157? You better check me. I don't know if I did that right.
157.
Okay. So I could just write it like this then, right? I could write it as, well, I mean, I just write it like that if I wanted. That's okay. I mean, that's an okay answer. I want the greatest, so I'm going to take the plus version. But that is an exact answer, right? And that's okay. Do we need to really simplify that? I mean, no, we don't. Because most likely what we're going to end up doing is always rounding that to some decimal anyway. But if we write the answer as an exact answer, we could always put it in a calculator and get a decimal that is as precise as we need it to be, right? Does that make sense? Yeah.
So the 17 plus square root of 157 divided by 6 is the same as negative 17 divided by 6 plus 157.
Plus the square root of 157
Yeah.
divided by 6. I could split it into two fractions.
So the bottom one.
Right. So this would be, I needed to do that. You're right.
Oh,
Yeah.
okay.
Sorry, I didn't finish. But probably this would be an easier way to do it. And if I just put that in Moodle, then isn't that just going to look like? Well, you tell me. What would be the buttons I would push to put that into Moodle?
Negative 17.
Okay, but first,
Parentheses.
yeah, I got to open a set of parentheses. Negative 17.
Plus squared parenthesis
Parentheses.
157 parenthesis.
Good. So that's the whole top now enclosed in a quantity.
Divided by 6.
There it is. Right? And always, of course, hit display response and see if it looks right before you hit, you can tell.
Oh,
If it doesn't look like that, then don't hit submit. Try it again, fix something before you hit, because display response does not grade it. It just shows you it renders it as a algebra view. Yeah.
So if you put that in as a decimal too, would it be wrong?
I think you can put, if you put in a lot of decimal places, I think it would work.
But better.
But it's so much safer just to put it in like that, because when you hit the display response, you can literally see if it doesn't look just like that, then something's wrong. Okay? And you know to go back and fix it. You can just keep doing that until you get the answer that you want, then hit submit. Okay, find the greatest real solution to come. Okay, so I mean, we're just trying to find the answers.
I have to go to 2.
Okay, and so there's lots of ways we could do this one. As long as you get the right answers, you're going to get credit on this one. But what is the easiest way?
Or you just divide by 5.
Exactly. So divide both sides by 5, and that's going to give me, I have to divide term by term, so x squared minus 4x plus 2 equals 0. right? And if that factored, but it doesn't factor, so quadratic formula. But at least we're putting small numbers into the quadratic formula now, right? Instead of having to put these big numbers in there. Okay, and this is it. And this was I can't believe this one, people missed this one, honestly. This is a really easy one.
Not the same thing we just said.
Well, this is adding though, this isn't even multiplying. So what do we do if we're just adding? Combine like terms, right, exactly. So if I add up the constants, 12 plus 3 is 15, 11i plus 15i, and they want to know what is b, so what's b? 26, yeah, you got it. Okay, make sense? How we doing?
7.
All right, so any other questions? I mean, those are the ones I identified as being kind of the tougher ones.
This is the non-graph.
Non-graph.
Can you go over the one that you left up on yesterday, because I had to leave right before you.
Yeah, you bet. Let's go back and let's take a second and review that one. Do you have another question, Luke? Yeah.
Yeah, I don't know how to factor, like, spurs.
Oh, okay, we'll do one of those too.
Yeah.
How to simplify square roots?
Yeah, like when it says like simplify, like the spur, like 27.
Yeah, okay, it's no big deal. Yeah, we'll go through one of those too. Okay, so on this one, remember, and this is probably a good one to maybe take a second look at, because this is the hardest thing on here, I would say. So the most involved process. So if we want to solve this one, not graph, but solve this inequality in one variable, only x is there, right? Remember what our trick is. Our trick is, if we have a graphing calculator, we could just graph the parabola. But we don't even need to, we can just sketch it. We know that if I were to graph this parabola or sketch it, it's an upward opening parabola, right? And when we interpret this statement, we want to know when is this quadratic expression greater than or equal to 0. That's the same thing as saying when on the xy plane is this parabola on or above the x-axis. The statements we make here are always going to be relative to the x-axis, right? If we want to know when this thing is greater than 0, y values are greater than 0 when we're above the x-axis. If that had been less than, it would have been below the x-axis, right? The on part just comes from the fact that we're actually including that equal sign, okay? And so then if we just look at our sketch and we ask ourselves the question, when is this parabola on or above the x-axis, which we just arbitrarily drew in there. This isn't supposed to be accurate. It's just trying to get us an idea of what the solution is going to look like. Is it going to be an and inequality or an or inequality? Which one? Well, in this case, it's going to be or, because if the parabola is opening up, and we're looking for the part that's on or above the x-axis, then that's going to be the tails of the function, right? Not the loop of the parabola. It's going to be the tails, which just go on forever, right? And if I'm looking for those x values, well, what are the x coordinates of all those values? It would just be, in other words, if I were to squash this parabola down onto the x-axis to see what the x coordinates were of all the points, it's just going to be the parts that are outside of the x-intercepts, right? So clearly that's an or inequality. Or is on a boat, right? Does that make sense?
What is an and?
Okay, it'd be an and if the part we were looking for was the loop of the parabola. So in this case, if we had an upward opening parabola, and this had been like a less than sign instead,
Oh.
because then we would have been wanting the parts below the x-axis, and that would have been the green part, right? And so those x values would have been the ones in between. Or conversely, what if we had wanted, we were looking on or above the x-axis for a downward opening parabola?
How do you know, like, the 2 and 4? Like, how did you?
Okay, so how do we know those? Now that's where we actually have to do some algebra. So at this point, all we know, we don't know the pink stuff. That came later. But what we do know now is that this is an or inequality. So my answer, and because I'm actually including those x-intercepts, it's going to be x is less than or equal to whatever that x-intercept is. We didn't know at the time. Or x is greater than or equal to the greater x-intercept, which we still didn't know. But to find those, all we have to do is take our quadratic inequality, and instead of an inequality, we'll just solve the equation where it equals 0 to find the x-intercepts. We want to know when is this parabola or this quadratic expression equal to 0. And we've been doing an awful lot of that, right? There's the equation we end up with. which in this case we could solve by factoring, but we could always solve by quadratic formula also. And then when we go through that process and we found that our solutions were positive 2 and positive 4, well, obviously 4 is greater than 2, so the 4 must be the right one, and the 2 must be the left one on the x-axis, correct? The one thing that I still see people doing a little bit is when they factor this thing, no, don't make this mistake. When you factor this thing, the magic numbers of -2 and -4 are not the solutions, right? Those are just the magic numbers. To get the solutions, to solve the equation, I still have to set those factors equal to 0 and solve, which means I'm actually going to get the opposites of the magic numbers, right? Yes, ma'am.
But you can use the quadratic formula.
But
Just
you-
go
yeah,
plus and minus.
You,
not
exactly.
the
You
same
can always
things,
use the
right?
quadratic formula too. It's just that if you can factor easily, it's a lot quicker. Okay?
So it tells you what is an and or one? It'll let you know.
No, you have to decide that, but that's based on your sketch, right? So there's two parts to this. There's kind of the first part, which is we're going to make our sketch, and we're going to see what is our answer going to look like. Is it going to be an and, or is it going to be an or? Right? In this case, it's an or, because we had an upward opening parabola, and we were interested in the parts that are above the x-axis, which meant the tails. You can always make this correlation. If the part you're looking for corresponds to the tails of the parabola, it's an or, right? Because you're looking outside. If the part you're looking for, based on the original question, ends up being the loop of the parabola, it's an and, okay? Because it's trapped between the two, right? Okay. All right, now Luke had a question. Let's do one of these real quick. How about simplify the square root of, what are we going to do? How about if we did the square root of 128? Okay, so our goal then, when you're doing these, all you ever do is we want to decide if there is a perfect square factor of the number in the radical, and if so, find the biggest one. And we're just going to break it up into, like in this case, this would break up into
16.
the square root. Actually, we can do bigger. We could go 64 and 2, right? Because 64 is a perfect square. It's 8 squared. So then this is just going to become an 8. And I get 8 times the square root of 2. Now, it doesn't always work. If I started with the square root of 111, there's no perfect square that goes into 111. And so that's it. I'm stuck. I can't simplify it. You can only simplify it if there's a perfect square that divides into that. Okay? But the ones I give you are all going to have perfect squares. And if you want to just make a list for yourself, just do that. You know, 2 squared, 4 squared, or 2 squared, 3 squared, 4 squared. Just make a list on the paper and just go looking for them. Yep.
Are you gonna be in the lab this period?
Yes.
You are. Can I come and test because I really need to get.
I'm thinking I'm going to try to maybe do that. It just sort of depends what the situation is. I mean, if you're not in this class, come and check it out. I'll try.
What
try
lab are we
to.
going to?
I don't even know yet. I think 205.
Are you gonna meet everyone here first?
No, I think we can just go down.
Okay. Going to 205. Hopefully.
Yeah, hopefully if it's open, we'll go 205. Okay, I think we're okay then.